Good morning one and all. I am T Gayatri, an associate professor in the Department of ECE at Reddy College of Engineering and Technology. Welcome to Microwave Engineering subject series. Today's topic is travelling wave tube. Travelling wave tube is also called TWT. Now, travelling wave tube is a O-type category of microwave tube. This is the diagram. This is the entry point of the slow wave structure. Here the RF input, RF signal is given as input here and the RF signal is taken output here. Now this part of the device is called collector. The collector are also called anode of the structure. Now this electron gun is subjected to the negative RF input. Now because the electron gun is subjected to the negative RF input, this is the heater. So the electrons are emitted from this electron gun. Now the emitted electrons are monitored by these focusing electrodes. These are the two focusing electrodes. The focusing electrodes will monitor the electron beam to go in a straight line. So RF input and the electron beam interact here throughout the tube. And when RF signal is taken as an output, the electron beam will continue with usual velocity and it will be collected by this collector. This device is called travelling wave tube since the electron beam and RF signal are interacting during the travel. Now these electrons are also monitored by the attenuator and a series of setup here. Now the difference between the klystron and travelling wave tube is, in the klystron the electron beam will with the standing wave of RF signal, but here the electron beam is interacting with the travelling RF signal, hence it is known as travelling wave tube. And because the interaction time is more, the amplification of the signal also is more here compared to the klystron. Now this is also called as distributed interaction. Now the principle is explained here. The RF signal is made to slow down because of the slow wave structure. The slow wave structure can be like this. It is called as a helix, or we can use a back line, or we can use a corrugated line or single side corrugated line. So these all Now the reflection spot. I want to ask a question. What is the need of slow wave structure? The need of slow wave structure in TWT. Please think and answer this question. The answer is the slow wave structures like these structures are needed in travelling wave tube to improve the efficiency of the travelling wave tube and to increase the gain of the signal. I will tell you with a simple example. For example, a faculty is interacting with the students in the classroom, and if the faculty speed is more than the student speed, that is the faculty talking speed or the voice speed is higher than the student speed, then the student will be unable to understand what a faculty is speaking. So, here knowledge gain will be 0 or very less. Now, if a faculty is talking very slow compared to the student speed, the student will not be able to listen to the class and the student will not be interested in the class. So, the better efficiency or better output or better knowledge exchange will happen only if the faculty speed and the student speed is equal. They can interact for longer time and more knowledge can be exchanged. Now, in the case of travelling wave tube, the RF signal actually has a velocity of the light. Now, because the velocity of the RF signal is very high compared to the electron beam, the interaction time will be very less and the efficiency will be very less. Now, here because of the slow wave structure, the RF signal is made to slow down to the velocity of the electrons. Now, when the RF signal is travelling this way, the electrons also will be in this mode only, here only. The interaction will happen. As they will travel together, the RF signal will go like this and the electrons will go like this, but they travel together and the interaction will happen throughout the tube. Now, when RF signal will leave the tube, the electron as usual move with its regular velocity and it will be collected by the collector. So, here we will get maximum efficiency since we are using slow wave structures. The slow wave structures will make RF signal velocity slower, or they are brought down to velocity of electron beam. So, this is the principle of TWT. The RF signal is brought down to the velocity of electron beam and they both will interact during the travel. Hence, we will get more efficiency compared to the klystron. TWT has more efficiency more gain and wide band amplifier. Thank you. We will continue in the next class.